So next question we are having. So we need to prove that this expression is it is an increasing function in first quadrant. Okay. So what is the condition for function to be increasing in an interval? That means which is the derivative of the function must be greater than 0. Okay. So let us find dy by d theta, since the other parameter is theta on the right hand side. Okay. So meanwhile, I'm solving this. You can also try this question on your own. So I've solved this derivative and I can see that this derivative is positive always actually, because it's the square of something. Since it is positive, so we can clearly say that function is increasing in the given interval. Okay. So moving on to next question. Find the interval in which this function is strictly increasing or strictly decreasing. So again, same method. Firstly, we are going to find the derivative. Okay. So what is going to be f dash x? 3 cos 3x plus 3 sin 3x. Okay. So we know, okay, let's take 3 as common. Cos 3x plus sin 3x. Okay. Then, okay, I don't want to deal with cos 3x and sin 3x. I want to deal with only one trigonometric term. So I'm going to do 3 root 2 and take 1 by root 2 inside. Sin 3x. Okay. Okay. So now I'm going to, okay, so we can write it as sine pi by 4 and this as cos pi by 4. So sine A cos B plus cos A sin B, which becomes sine 3x plus pi by 4. Okay. Okay. So we know x is going from 0 to pi. 3x is going from 0 to 3 pi. And 3x plus pi by 4 is going from pi by 4 till 3 pi plus pi by 4. Okay. Okay. So now what we'll do, we'll assume 3x plus pi by 4 to be some variable t. So we know ft is equal to 3 root 2 sine t, where t belongs from pi by 4 till 3 pi by plus pi by 4. Okay. So we need to find where this function is increasing or decreasing. Okay. So what we'll do, we'll simply just plot the graph. Since the x-axis, the we have to consider only positive term on x-axis. So I'm going to make the graph on this side only. Okay. So okay. So this is 0. This is pi. We need to analyze somewhere. Here will be pi by 2. And here in mid, there will be pi by 4. So we need to analyze our graph from pi by 4, this red line, till I'll complete the graph. I guess we will need to extend it further. 2 pi, 3 pi, and somewhere here we'll have 3 pi plus pi by 4. So between these two red lines, we have to analyze a function. We have to check where it is becoming positive and where it is becoming negative. And where the function will be positive, the derivative will be greater than 0. That means the function will be increasing. But remember, the function is ft, but we have to analyze for fx. So when we'll check for the intervals of t, then we'll substitute t as in terms of x, that is 3x plus pi by 4. Okay. Okay. So how many points, interval points are we having? This one, this one, this one, and yes, it's changing. Function is changing sign here also. So this one and this one. 4 points. Function is positive here, negative here, positive here, and negative here. Okay. So we have to tell whether the function is strictly increasing or decreasing. So from here we can clearly see a part for increasing. T belongs from pi by 4 till pi. Then union, then this region, 2 pi by 4, sorry, 2 pi and 3 pi. Because then it's negative, which is none of our concern for increasing. Then for decreasing, t will belong from pi to 2 pi union 3 pi till 3 pi by 4. 3 pi plus 3 pi by 4. Okay. Then we'll substitute t as 3x plus pi by 4 in both the cases. And then we'll get the intervals for x. Okay. Then we need to make the standard graph, which will be mentioning all the, how many intervals we are having? 4 intervals. So we'll be mentioning all the 4 intervals, like I previously mentioned in other questions also, that we need to make a graph starting from, the x is from pi by 4 till pi, sorry, t. And then t is from pi till 2 pi. T is from 2 pi till 3 pi. And from 3 pi to 3 pi by 4. Then we'll check for 3. We will make 4 cases. Then we can't do this by graph method directly in CBSE. We have to take some mid value and then we have to prove that the function is positive or negative there. Okay. So don't do this directly. This is for just your reference. Okay. Then you'll make 4 cases separately for these intervals and you are going to fill the table. Okay. Since I already told this previously, I'm not going to do this again. So I just have written this for your reference. You can substitute for x and then you can get the final answer. Moving on to next question. Okay, so the next question says, show that the equation of normal at any point t on this curve and y is equal to this is this. Okay, so we need to find the equation of normal at any point t on the curve. Okay. So the x and y are written in parametric form. We can clearly see it. Okay. So we know the slope of normal. So first I will write the slope of tangent. This is the slope of tangent. And the slope of normal is negative of the reciprocal of that of tangent, which is this. Okay, don't write this in exam. This is the slope of normal. Okay, so we'll write the general equation of y minus y1 of normal. So this is the equation. Okay. So we know the points. We know y1 and x1, which are already given here. But we don't know the m dash. Okay. So we need to find that. So let's see how we are going to find. Okay. So let us write the slope of normal in a different way. Okay. So we can write it like this. I hope there will be no problem if I write it by this, right? Because it will cancel and it will again become minus dx by dy. Okay. Can I write it like this also? I hope again no problem. So now what we have to do, we have to find dx by dt, dy by dt, substitute in this, and then substitute m dash in this equation. Okay. Let's find dx by dt first. Minus 3 sin t plus t cos squared t into right. And then dy by dt. What is y? 3 sin t minus sin cube t. Okay. So y is 3 sin t minus sin cube t. So it's going to be 3 cos t minus 3 sin square t into cos t. And I'll write the x coordinate also. Cos t, 3 cos t minus cos cube t. So x is same. So now I'm going to make the final equation. We just simply need to substitute qt is equal to m is going to be negative of minus 3 sin t plus 3 cos square t sin t upon 3 cos t minus 3 sin square t cos t into x. X minus 3 cos t plus cos t. Okay. Then we have to do the tough part, which is cross multiplication. I hope something will be cancelling here. Why? Okay. Hmm. Then we need to solve this very bad expression. Let me just solve. I don't think this is going very well because it's very long. I think we have to somehow simplify it because this is not going to work like this. Let us try to simplify the slope of normal, which is inverse which is 3 sine t. I'm taking this negative side inside. 3 sine t minus 3 cos square t sine t e cos t minus 3 sine square t cos t. Okay, I think I can see something. Firstly, 3 is going to cancel out, and then we can take sine t as common in here, and vice versa. Okay, so this is the thing which should click to us at the time of exam, because CBSE is not going to expect us to solve this big expression in exam and waste our time. They will be hinting us. So whenever you see something is going very long, try to see the scope of simplification. I hope some of you might have found this thing here only, which is very good. I'm going to further write. We know 1 minus cos square t is sine square t, and this will become sine cube t upon cos cube t. Okay, so now it has simplified. So this is our m dash. So let us write our expression again. Okay. So y minus 3 sine t plus sine cube t is equal to sine cube t on cos cube t, x minus 3 cos t plus cos cube t. Okay, and it will become y cos cube t minus 3 sine t cos cube t plus sine cube t cos cube t. I think this term is going to cancel out, because on right hand side I am having x sine cube t minus 3 cos t sine cube t plus sine cube t cos cube t. So this thing is going to cancel with this. So I'm going to separate x and y terms. Minus x sine cube t is equal to, okay, I'm 3 sine t cos cube t minus 3 cos t sine cube t. I can see I can take a lot of common in this. Sine t cos t into cos square t, and here I'll get minus sine square t. Okay. So one thing which we must aware of, I'm going to write 2, 3 formulas, which is cos 2t equal to cos square t minus sine square t. 2 cos square t minus 1, which is equal to 1 minus 2 sine square t. So these are some formulas which we must remember. Plus sine 2t is equal to 2 sine t cos t. These are very important formulas. So since we want that expression, so first we will see what we have to do exactly, which is remaining. So we are having an expression of 40 sine 3 sine 40 on right hand side. Okay, so to make it 40, we have to use formulas. Okay, so I can write it like 3 by 2 into 2 sine t cos t, and I can write this expression directly as cos 2t. and it is also sine 2t. Okay, so it will become 3/2 sine 2t cos 2t. Okay, then 3/4 sine 2 sine 2t and cos 2t, which is going to become 3/4 sine 4t. And this 4 is going on left side. So we get a final expression. This is a hence proved. Okay. So this was just much of a calculative question.